Everybody, welcome back. In this video, what I want to do is continue talking about indirect proofs and how and when to use them. So both these problems here are going to require indirect proof, but don't jump straight to indirect proof. At this point, everything that you should do should go through this procedure. Think of this is what to do. This is your repertoire, this is your inventory of moves that you've got. You should try them out in this order. If you do them in this order, you will also, or at least you attempt to do them in this order, you will always get your problems done in the most efficient way possible. So try arrow out, try bonus tolerance, try and out. See if you should do an and in. Here we needed an and in to make the contradiction here to complete this indirect proof. So look, can I do this? If so, do it. Can I do this? If so, do it. Can I do this? If so, do it. Should I do this? If so, do it. If you can't do any of those things, see if your goal is an arrow and do a conditional proof. Provisionally assume the left side, try and get the right. If you can't do any of these 5 things, then do an indirect proof. That's where you provisionally assume the opposite of whatever it is you're trying to get right now, whatever your goal is at the moment, and get any contradiction, any 2 opposites, and stick them together. But that should be your last resort. Don't start with this one. There may be times later in the semester where that's appropriate, but let's not do it yet. So let's take a look at this second one here. We've got E arrow F and not E and F. Can we do an arrow out? No. By the way, we're trying to solve for not E. Can we do an arrow out? Nope. Modus tollens? Nope. And out? Nope, because again, you might think, oh, I can separate the E and the F apart. That gets me not E and not F. No, it doesn't. If an and is in parentheses, especially with a not on the outside, that is locked in. You cannot mess with anything in there. Neither is it the same thing as, oh, that's the same thing as not E and not F. Separately. No, it is not. And we'll see a little bit why, when I talk about disjunctions later, you'll see why that's the case. Can I do an and in? I can. Should I? Anding these 2 things in together is not going to get me anywhere closer to not E. So the answer is no. Is my goal an arrow? It is not. What does that mean? It means that we're going to employ indirect proof. Now, what we do in indirect proof, again, is we provisionally assume the opposite, again, technically the contrary, of whatever our goal is, and then we try and get any 2 opposites, contraries, and stick them together. We do that, and we will have proven not E directly. Now, since we've got not E, we want to provisionally assume the opposite of that. That would be E. You could put not E and then double negate it down to E, but I think it's obvious that the opposite of not E is E. That's our provisional assumption for an indirect proof, which means if you're starting an indirect proof, now what we need to do, your mission, now that you've started this, is get any 2 opposites and stick them together. Any 2 opposites and stick them together. Know what your mission is at the moment. Don't mix it up with arrow in. Just like if I tell you to go to the grocery store to get some orange juice, and then you come home and get some milk, you have not accomplished the task that I set out for you. So in this case, when you're doing a provisional assumption for an indirect proof, finish the job. In this case, get 2 opposites and stick them together. If you're doing an arrow in, provisionally assume the left, get the right. Don't mix them up. So now with that E there as a provisional assumption, we're trying to say, hey, if this were true, which is what a provisional assumption is, if this were true, would it lead to absurdity? Would it lead to contradictions? That's exactly what we're looking for. You use this kind of argumentation if you've ever had a discussion with, say, a friend or maybe even an enemy, and someone says something that you find ridiculous, and you say something along the lines of, yeah, but that's like saying, or if that's true, that would lead to this, and that's ridiculous, so that's why your position can't be true. That's the exact kind of reasoning you're using in those situations. That's what we're doing here. Well, let's do it formally. Now with that E there, can we do an arrow out? Yes, we can. That gets us F. How? Arrow out, 1 and 3. Okay, now this one it's a little bit less obvious, but let's go down the list. Can we do another arrow out? No. Can we do a modus tollens? No. Can we do an and out? Again, that's still locked. No. Can and should we do an and in? And what you're looking for at this point, and a lot of times when you're doing an indirect proof, you are going to do an and in. Can I build something? Can I put things together that would get me opposites? Well, I can't mixing this with this wouldn't get me opposites. Mixing this with this wouldn't get me opposites. And here's the deal on indirect proofs often. Look for what you already have nots in front of. So look, we've got not E and F in line 2. So what you should often look for in an indirect proof is, well, if I've got something with a not in front of it, can I build the opposite of that? We've got not E and F. What would be the opposite of not E and F? Just plain old E and F. Do I have the pieces to build that? Yes, I do. So when I build that, and I should, I get E and F, and in, 3 and 4. Now look, my line 5 and my line 2 are opposites of each other. A little bit bigger than the opposite that I got in this problem, the contradiction that I got in this problem, but it's still a contradiction. So now I'm going to take these two contraries and stick them together. E and F, I'm going to add join them, and not E and F. And that's and in 5 and 2. And I have thus indirectly proven, well, I've directly proven that if E is true, it leads to absurdity, which means we know that E can't be true, so that means not E is true. Indirectly, from where we provisionally assume the opposite in line 3 to where we got a contradiction, in this case, in line 6. This one, for the sake of room, I'm going to scoot over just a little bit. We got not G arrow H as our one and only assumption, and we're trying to get not H arrow G. Well, can we do an arrow out? Nope. And out? Nope. And in? We can't here. Not only shouldn't we, we can't. We only have one thing. Is our goal an arrow? Yes, it is. So your temptation here might be, oh, we're doing indirect proof now. Let me go ahead and provisionally assume the opposite of the goal. Don't do that. Okay? If you can do this, go ahead and go for this. So what should we do? Provisionally assume the left, solve for the right. The left here is not H. Provisional assumption, this is for an arrow in, which means we're trying to get right now, we're trying to get G. That's what we want. Now, take a look. Can I do an arrow out? No. Can I do a modus tollens? Actually, I can. And this is the simplest way to do this problem. Could do this problem with an indirect proof right here. You could say, I'm solving for G, so I'm going to provisionally assume not G. You would get H and not H, and you could stick them together as contradictions. But I told you, if you go through this method, it will get you the most efficient results. So take a look here. We started an indirect proof. I'm sorry, we started a conditional proof. And we could do the indirect method here, but the modus tollens will actually get this done sooner. Both would be equally correct. This one's just more efficient. Arrow out? Nope. Modus tollens? Yep, because look, I have an arrow and I have the opposite of the right side. That means I can get the opposite of the left. The left side is not G. What will be the opposite of not G? G. That's what I was trying to get. How did I get that? Modus tollens 1 and 2. Which means I provisionally assumed the left and I got the right immediately. Which means I have proven not H, arrow G is a thing with an arrow in, and this is going to sound strange, but it is 2 through 3. Because from where we provisionally assumed the left to where we got the right. And that is the most efficient way to do this problem. Again, there is a less efficient way, which I'll go ahead and put up here. We've got this. We do the same thing. We're going to provisionally assume the not H. But let's pretend we can't do modus tollens for a moment. We're going after the G. What we decide to do is, instead of just doing a modus tollens, if you didn't see that you could do that, you could say, okay, I'll provisionally assume not G for an indirect proof. That means for this, I'm after two opposites and sticking them together. Give an arrow out, get H, arrow out, 1 and 3. Then I got two opposites I can stick together, H and not H, and in 4 and 2. That part's done, which means I was able to get the G here, indirect proof, 3 through 5, from where I provisionally assumed the opposite to where I got a contradiction, which means I was able to get the whole thing, not H, arrow G, with an arrow in 2 through 6. Now, both of these are equally correct. This one's longer, this one's shorter. It will get you just as many points either method you go. But like I said, if you follow this list and you just go straight to this list, can I do this? Can I do this? Can I do this? Can I do this? It will always get you the most efficient results. Okay, so in the next video, what I want to do is say a few things about translating some more aspects of negations. I think that's what I'm going to do, or do some more things where we're translating negations.